be like a 2-hour movie. So what sequences we're making? You got some DNA and RNA.
RNA, yeah.
And how much of each? Like how many different sequences?
I think 6.
6 sequences.
DNA sense and antisense, RNA sense and antisense, and then the all F
Okay.
sense and antisense
Okay.
as well.
So we'll probably do the all F another time.
Okay.
But I think we could do the DNA, both of them, and then the RNA sensing, and then we'll do wild type, luciferase, and yeah, and then most good we could tomorrow try the soil and stuff for genes.
Is it fine that they have the alpine, the sense?
Oh, the ones you want to make today? Yeah, we should do that. So there's an alkynyl phosphoramidite modification on a couple of her DNAs, one of her DNA and RNAs. It's like a specialty, right? And then we can try that.
We could, I won't be able to help you on
It's
flow
the same-
times and things like that.
Oh,
So
yeah.
if you already have a synthesis,
Yeah,
It's
we've done
the
it.
same as everything, yeah.
And one thing is that last coupling, there is no DMT on there, so we can monitor if that last coupling works. A lot of that's on us.
Okay.
I'll have to grab it.
Okay.
Squeeze past you.
Yeah, but they're like the standard commercial antibiotics you get from Glen Research or Kenji.
Okay. Yeah, so here I think we're just going to basically tell it what symbol we're using in the RNA and then what bottle that attaches to. So it should be very straightforward.
Is there a pattern where people use RNA on these bottles like that you've seen? I guess it doesn't matter.
You know, it does, because each one is different and that controls the number of these letters that they have, the extra aminites. So it's hard to.
Like, I'm just thinking sort of visually, but we have, what do we have? A, I don't know, C, G, T. Like, it almost makes sense to have the RNAs kind of behind them.
Yeah.
Like A, C, D.
But you can also do it through this manual control screen if you like. You know, you can say this side is something. So you got the A and the C. So, but you got the FIL and your sulfurizer right here. Then you've got your OUZE and your other S's. And down here, yeah, your D, J, K, N, Y, Q, R, S. That makes sense. The D and the J are the small ones. So basically, K, N, Y, Q, R.
It's not really in that order, or is it?
This you could put in any order you want. You know what I mean? It's, you can just turn this one over here and put that one over here. You know?
Oh, okay. Right.
So,
Yeah, okay.
but whatever works for you is the best way.
Yeah. Well, I think we'll highlight Madden and done kind of design.
Yeah, so you got the ILK. QU.
still don't have any. I must have forgot to order it last time I made it. Or used it all. So I made a lot.
But what we could do is
We can make it up till the
make
end.
it up to the end,
Yeah.
and then later we'll just do that coupling on the column. We do that often because it's a
Basically, put
five.
the column back and do a single coupling to it.
Yeah.
It's a 5' model.
Do that all the time.
Yeah.
Sometimes I have to make them in pieces because I have to like use. Well, we only had like 5 spots on our old synthesizer, so I had to make like complicated RNAs in different pieces. So it doesn't. Yeah.
And then you store it in the fridge or freezer it, and then bring it out, thaw it out, and put it.
Yeah. So on the column, it's really stable. So it'll stay in the column like a year or 6 months or whatever. So then just.
Okay, I was worried about having stuff in my toolbox coming back home, but that sounds like it's not a problem.
As long as it's on the column, it's good.
Yeah, okay.
After deprotection, it's not stable because
Yeah.
then everything's free, right? All the groups are able to react with each other. But on the column, it's good.
Yeah. Let's do that. And then let's order some more documents on this.
Yeah. Do you know how much you want to order?
Of the Alkine?
Yeah. It's kind of expensive.
Yeah.
But how much Daisy? How much do you think you'll need of the Alkine? Like how many more sequences? Like lots? Like lots and lots?
Well, I was thinking 4 columns for each one, the DNA sense and RNA
But then,
sense.
yeah, like we make this batch, but then after that, how much do you think you'll need? Don't know.
No, not really.
How much is it? $1 grand?
It's like $400 or $500 or something, I think. Let me check.
Yeah. I mean, I'd say probably order at least 2. I'm trying to go through there.
So there's a couple of things I need to go over and just to make sure that we have. In the oxidation subroutine, that's where we empty out the trial monitor. So in other words, we do the deblock, we leave everything in there, and then we say, okay, get a picture of the trial monitor, we say, okay, good. But during the coupling, it all stays in there. In the oxidation step, anything with a less than 10-second wait time, so a 9-second wait time, actually purges out the trial monitor. So these 2 waits in the oxy subroutine actually do the purging of the trial monitor.
Oh, okay.
So that has a dual function. And also, there's what's called wait for thio. And these 2 only apply during the sulfur routine. So this is where you would add your extra sulfur weights.
Add the extra sulfur
Weights, yeah. So in a normal oxy, this is flying along here and it just bypasses these.
Yeah. So if we're doing
No
file
erase.
and then, so is that the extra from the coupling time that
Yes.
Matt was talking about?
Yes.
Yeah.
So if he needs extra coupling time, this is where you get it.
Yeah. Hey Matt, you
This
may
is where
want
you get it.
to check this out. So you had that question about like how violation takes longer?
Yeah, so there are 2 things I was wanting to tell you about in here. In this oxy subroutine, this is the oxidizer subroutine. These wait times being less than 10 seconds, so 9-second wait times, this actually has 2 functions. This actually is where the trial monitor is empty. And if you try to put 10 seconds there, it won't recognize that as empty the trial monitor. So it has to be 9 seconds, and he's doing 2 here, so you can definitely say we're at the trial monitor. This is called wait for thiol. And this is where your wait times for your extra wait times for thiol go.
Sure.
So in other words, when it's doing its oxy, it goes through this routine and just bypasses those, and just keeps going. But when it's doing a thiol, it actually stops and waits this time.
Right.
So that's 90 seconds.
Yeah, twice.
So that's 3 minutes.
Yeah, 6 minute total.
So it's probably been quasi optimized already. Like, what do you normally call for oxidation time? 4 minutes. 4 minutes. I would say try it first and then always increase it.
Sure. Yeah.
Okay. Well, that's good.
And then there's what's called wait for modifier, and that happens if you're using one of these others besides AGCT. So in a normal sequence, if you're not using one of these extras, it just bypasses those WMO, wait for modifier, and wait for thiols. It just bypasses them. But if you are using the thiol, if it sees that the base that you're connecting is a small case base and it's going to use thiol, then it does wait for these extra times. The same as if you are using one of these, like a G or a Q or R, then it's going to go ahead and wait during that wait for modification.
Sure.
And I'll show you the step that has wait for modification. Typically coupling. Yeah, so here's the wait for modifiers. So if you have another amidite that needs more wait time, this is where you put that. Because normally, AGCT is just going to bypass those two. Just go right down. But if it sees it's not AGC or T, it's some other, then it's going to go ahead and incorporate these weights.
So it does them instead of the 120? Like if it's
It does the 120 and these extra weights.
oh yeah, so
So
it'll be
this
like 6
120,
minutes.
it was 60. We changed
Yeah.
it to 120, which we probably don't really need that, but
But if I
it
use
worked.
one of the other bottles, it'll do all 3 wait times.
Yes.
Okay.
Just going back through my notes, making sure I didn't miss anything for you. Yeah, single digit wait times, less than 10 seconds, sends gas to trial monitor for about 17 OH only applies to S1. Now sequence your capital letters use oxy, lowercase, use thiol, S1. Thiol writer does not have Q, E, and F. That's interesting.
But they're all capable of either oxidizing or thiol.
So what he's saying is the thiol writer doesn't have Q, E, or F. So those 3 you can't use with the thiol writer. So
Which one?
Q, E, and F. So maybe you use those, map those to something in the RNA, or
So you can't violate those 3.
you can't use those in the thiol sequence. Yeah,
So,
the writer doesn't have it. So
so we should just not use it.
not use those except if you want to map in an RNA. You can use them for RNA, just not thiolated RNA.
Right.
Yeah, but sometimes it's violated or even in
So you can't use them in the violation program at all? Like the Q and the F? Like nothing?
It doesn't have them in the writer.
Yeah, so you can't use them at all for the violation.
Yeah, it looks like,
editor.
yeah, it looks like there aren't 20 of them.
Yeah.
I guess
So it says there's no Q, E, or S. Yeah.
it's 12 total.
But for the DNA and the RNA, you could use Q, E, and F. Just not if we have to violate the sequence.
And like I said, you can always map it to something else. This, you can map it to a different bottle it has. 20 here. So 10, 1, 2, 3, 4, 5, 6, 7, 10, convert it to the model.
It's 10 different. So,
Yeah.
but you can only use 10 different spots.
So-
Or is it-
Yeah, so we can max use 10 different bases
Mm.
for a sequence.
Yeah. And then for dilation, there's 12. You know what I mean? Like, the software doesn't allow for it.
Yeah, software just doesn't have
Doesn't have.
EQ, E, and F.
Yeah. Okay.
So that means out of 20, it's got three missing letters.
Yeah, it only has 9 there for the violation, like 9 assignments.
That has a mix number, but
But for the A, C, G, and T there, that's pulling the DNA, A, C, G, and T, right?
yes, unless
Yeah.
you map it to something else, but yes. Yeah,
Yeah,
it is
you-
A unless you map it to something else.
Yeah. You have to know what you want to calculate
Yeah.
and plan for that modification.
Yeah.
You know what I mean? So there might be some restrictions. Right?
Right.
Okay. Well,
Just don't use like those 3, I guess, right now.
yeah.
Like just Q, E, and F are off limits, and
Yeah.
then
Yeah, a modifier is anything other than AGCT. 180 is the maximum hold time, so if you need more, you'll have to put it in another step.
okay.
Shortcuts from keyboard are in the menu. You'll see RNA sequencer to convert A to U, let's say. Or other aminites defining bottles. So here are some good ones. So in your methods, we talked about these. So DNA RNA standard is 40 to 200 nanomoles. So that's 40 to 200 nanomoles standard. So DNA RNA 1 micromole is 800 nanomole to 1 micromole. That's that guy. And our DNA RNA 10 micromole is 1 to 10 micromole.
Will you leave that sheet with us?
I can give you a copy of this for sure. I can do it with you because
Or I can
make a copy.
I can make a copy.
Yeah, perfect.
I can do it now. Yeah, no, that answers one of the previous questions. Oh, current protocols.
Yeah, do you want to make a
No, it's like, I mean,
This is
no, I mean, we know this.
Okay, yeah, this is that's
Yeah.
paper
No,
that
we
I use
publish
every
it.
once in a while.
I'll just run to the photocopies.
We gotta assign the RNAs to bottles and like program it in kind of thing.
To continue on.
Like your outfit. This what? Yeah, man. Out in the fields, hoeing potatoes. It's great.
It's Colin's birthday, right? Did he show up? 'Cause I'm pretty sure.
Eventually.
Oh, he went to sushi.
Did you guys have something yesterday, like this or not?
Not entirely sure. I think they need to. Oh, like training wise?
Yeah, yeah. We're gonna learn how to program it. And then add the anodites. And then set up some synthesis before the end of the day.
Have they determined where they want these yet?
Matt,
Yeah.
where do you want those RNA positions?
He said there's a U already assigned, I think.
Like, it doesn't really matter, but
No. It's U.
You on
okay.
you, I guess.
For you on you.
And then after that, it's just random letters, right?
Yeah. Step up from the other one for sure.
Over email? Yeah, over.
So you're gonna coil it. Pay close attention to this. Yeah, can you see?
Video of this?
Yeah, sure. We'll do the next one. Or maybe like after he gets us on and you can try.
And so what we're trying to do is basically coil it to where it stays in the bottom of the bottle.
Is it? Yeah. Okay, I'm gonna make a video of this for the next anodites.
He showed me yesterday.
Have you tried it?
Yeah.
Yeah. So. We may want to look at getting bigger bottles from Kenjins.
Yeah, so I think those are like 30 or 40 ml bottles. I think they might ship them.
Like the larger size, yeah, like the same amount of amidite, but in the same bottle, or larger amount of amidite.
Yeah, I mean, like for the RNA and the DNA, we could order like 2 or 5 grams or something.
Yeah.
But yeah, I'm always scared those little bottles are gonna fall over.
Yeah.
Then they're not gonna be in a liquid.
Yeah, this is really meant for scale up. Did you want to try one? Did you try one? Doing it, or did you just watch them yesterday?
I just watched them.
Yeah. So how about should we let Matt and Daisy try?
Sure.
Yeah, with your of course. What Matt goes first?
One small, one large.
Yeah, you try. Or who's going first? Hey, Matt can go first.
So all I'm really doing is trying to wrap it around my finger and make a coil, and then that coil I just try to bend and then straighten a little bit. Put the filter on the bottom.
Sure.
So just
You
push,
can-
push that thing and then
Yeah, if you push it in and then pop it. Yep. Oh, yep. Pull it up.
and that's just argon. That's kind of residual, like
Yeah, the argon's flowing constantly.
Constantly?
It's keeping that
I
everybody
mean,
else.
when it's closed, and it's kind of stuck.
right,
Once
it
you open it.
pressurizes to 6 psi and that's it.
Is this the filter?
Yeah, the little guys. The little tubes. And the bigger one, or you just have 2 of the bigger bottles.
Just go in the end, I guess. Okay, it's in. Oops. Yeah.
Yeah, and you make sure that the little pusher is out. Yep, it is.
Yeah.
All right. Okay, next, Daisy.
And if you find a pen works better or something else besides your finger to wrap it around, that'll work too. And then you can always straighten it when you get the bigger bottle. You can just pull, kind of pull down and it'll straighten out.
Yeah, we're looking to getting some bigger bottles, at least for DNA and RNA, maybe.
Guy who makes the glass is going to be happy.
Yeah, more money.
Yeah. I don't know if they would charge us more though for their glass bottles.
This might be heavier. But
Yeah. Maybe shipping, I guess.
Yeah, we gave you a bunch of extras of this size here. So. Yeah, I put the filter on after you coil it, just to,
Yeah, then you coil it, but you don't pull it.
Right.
Yeah.
and really what you want is you want to just kind of circle and stay on the bottom when you put the cap on. It just needs somewhere for that extra to go, so it's better if it's in the coil and absorb.
That's the thing. Yeah.
Should it be straight?
Yeah, it's not even. Just keep pressing it until you feel it. Feel like there you go.
Then you can see here at the bottom.
Mm-hmm.
All right, that's good.
Okay, so there's your DNA, there's your RNA. And so now we map.
Can we call it single? So then what do we call the DNA bases? Like if we're doing like a mixed RNA DNA?
You call them by the AGCU,
Yeah,
and we're mapping them to the bottles right now.
yeah. But what I mean is like
I think we'd have to use
we'd have to use a different
DNA.
letter.
Yeah, or we'd use the DNA editor and then map the RNA in that one.
Okay. I mean, we're not doing mixed sequences now. But
Yeah. I don't think they're meant to map the 4 DNA bases to the RNA editor. But yeah, we need to like pull T's and stuff for the RNA, like from the DNA.
Yeah. Is it good?
I don't really think you can see the screen.
A is Q, C is I, G is K, and U is U, RNA. So if you wrote a sequence that said A, C, G, U, then you convert it, it's going to be Q, I, K, Q.
So U is U. But what if we wanted to map T to the DNA T? Would you just put T there? And that'll pull from the DNA thymine.
Yeah. But what I mean is if we had a deoxy A with a ribo A, you have to call the RNA A something else or the DNA A something else.
Yeah.
You know what I mean?
Yeah, those first 4 are
Yeah.
mapped
Yeah.
here. So yeah, I'd have to call them something else.
What first four on that here?
So these guys.
Yeah, that's the DNA, and this is an RNA sequencer.
Yeah. So if we wanted to make like a DNA and RNA
Hybrid.
mixture, it'd probably be easier to use the DNA editor and map the RNA.
Because
Right.
those are fixed.
Yeah.
ACGT, right?
But it's mapping them for a sequence. You know what I mean?
Yeah.
But what I mean, what if we wanted DAs in here? We wouldn't be able to type A, because they would go to Q.
Yeah. So it'd give us all RNAs every time we
Yeah,
did
so we'd have to call this like B or something different. You know what I mean?
Yeah.
Yeah. I mean, we know how to work around that. Maybe for RNA, we'll just add a letter like B, D, H, and U. You know, just I don't know.
For the DNA.
For the something like that. Since we can't
Yeah.
do R, A, and DA,
Yeah.
but
So, with the basic sequence editor, so right now you would have a table that said your A, C, G, U, and then you would actually write the I, K somewhere in here
yeah,
in the sequence.
yeah. Well, we got options. Like we could do that.
And so are you running you're gonna run an RNA today with no thiol?
No, we need no thiol, but we need a thymidine on the end, which we prement, like in the overhang, like 2 thymidines, and then the rest is RNA.
So 2 T's on the end of
Yeah.
And so you'd be using this editor, and then you would just use the bottle names for the chemicals in the sequence, and then you throw that T in there.
Yeah,
Yeah.
at the end.
Yep.
Yeah.
That's probably the easiest thing to do.
Yeah.
Yeah.
You want to add the sequence? One of you guys? Yeah. Yeah. What do you do, Kevin?
Just type it out.
Yeah, type it out. But you gotta use the.
Yeah.
Yeah, we're in the
main.
And then we'll double
So I have
check
to
it.
use the
Yeah.
other like eyes and
Yeah, you use.
If you use these guys. And then T's.
So make yourself a little chart that says I equals what? Here's a K&A notebook. Propaganda. Got a mouse pad.
Is
It's a good thing I'm on sabbatical. Or wait, I'm not. But I know someone who is.
Working so hard. It's unbelievable.
A. Q is A. And U is U.
At least you is you.
Yeah.
I mean, it's no different than what you did there with 1, 2, 3, 4, 5, 6.
No different.
Yeah, it's the same
Right.
system.
I think you're going to be surprised at how closely that resembles it, and it might be because that was copied from that years ago, you know. So I think ABI kind of started that off, and a lot of them are just basic copies of that. But
No, that's
with-
a good
with-
machine.
Yeah, yeah, and this is just that with extra software stuff, and this software on this is a little bit older, but still real powerful. They're right now rewriting it. Our new Shasta, the big Shasta that we have, is got great software. You know, like this Century software, and they're rewriting this to match that. So you'll be able to run a different method on each and things like that you can't do right now.
That's the sunstrand. C U A
And do you have a method of checking this, like with mass spec or?
Yeah, and like your HPLC mass spec and the job.
Can I like backspace? Okay. I U U
think that macro is gonna work really well, because right now we were saying A and stuff, but you don't have to have A there. When you start a new sequence, I think it's blank, or you need to make it.
Sure.
So.
I did a test run. Yeah. Had good drills.
After we curled those tubes, because at one of the bottles, the tube was sticking out,
Oh, yeah.
and you didn't see it, and then so it get like two bases in and then die, and so once we figured out that, we were
Lots of troubleshooting. So yeah, making sure that the tube is same as the HPLC, right?
Yeah.
Like it's not in the buffer, then it's just pulling air. We don't want to blow the pump.
right. And this one, if we've already taken the throttle off, and then we add that couple and we don't couple, then we tap on top of that, we just kill the call.
Yeah, it's not that. So
Yeah, that's right.
And then you want to save it as something, so
Yeah.
say save as, and give it a name.
let's make another one here. How do you open a new one?
Oh, you just did so cool.
And the anti-sense is just the 5 and the 3 primal swap.
Yeah, it's the complement. So, so the first one we put in the normal way, and this one we kind of put in backwards, right? And it's just the complement to the 7 strand.
So you could theoretically couple those together into.
Yeah, so we make a duplex.
Okay.
So we make short interfering RNAs. So when it's a duplex in a cell, it causes silencing, so it knocks down gene targets. So it can have like the same molecular weight as something else, but if it silences, then it's the right sequence kind of thing, right?
By silencing it goes away in a way.
Yeah, it knocks
Yeah.
the gene expression
Yeah.
down. So
Yeah.
if there's like a high level of the gene, it goes to 0.
Yeah.
And sometimes that kills the cell. Like we do a lot of our tests with firefly luciferase, which is like what makes fireflies glow. That lets us like we test like different chemical modifications. So we're trying to see if they work in silencing and then whether they have like practical applications. Like the photo switch we made, so we can turn genes on and off. So that could help like attack cancer or use this tool to study gene pathways where we don't want to permanently disable the gene pathway, but if we turn it off,
Turn it off
how does
for a
that
time.
affect the cell? Yeah. And then if we turn it off for like an hour and then turn it back on, does the cell die or does it recover? You know, stuff like that. It's exciting, right?
Yeah, according to this book I just got, this is the physics of the 1905. You know, this is the RNA, it's the new science.
Yeah.
You're on the ground floor.
Alright. Alright, it's done.
Okay. So now what we do is we make a method using those sequences we wrote. And since this is 2-method software, we could actually run both methods at the same time. In other words, on different columns. So we could run 2 columns with one method, 2 columns with another method. So now is when you would go set up your method. And then you would pick your sequence. So in other words, first your method is going to be, you're going to want to say, I changed that one test D, I changed it to DNA, RNA, 1 micromole, 1 column. So that's probably the method you're going to want to use, but that uses these deprotect, coupling, capping, and oxidation steps. Right. And those are all those 1 micros, and we like them. We added the priming of the channel to that 1 micro detect, and in this coupling we changed the time So I think they're going to be pretty robust. This is what we ran last night.
Yeah, I think it'll be okay.
So all we're really doing then is changing the sequence, and we have pretty much the same branch for A, G, C, T, but let's look at I, K, and Q, U. There's one branch. So I has one micro branch. U. Oh, so it has one micro branch. U. So we better check these other things. So I has one micro branch. I. Yeah. So there's one micro branch. I, K. So it'd be best to open those up and compare them to the one micro branch. So subroutine will say, let's open one micro branch. And then we'll also open one micro branch I. Micro branch K. One micro branch Q. One micro branch U. Okay, so let's go compare those two. Two
Looks the same to me.
So those look good. So that's the I is good.
Gonna be a pretty sentences.
Yeah, I'm hearing two reading. That's fine.
Yep.
Here, I don't really want to make one. Just even this one over like,
Yeah, we need somebody for the picture.
John. Third Kevin's really good at nature.
That's the face he makes when he's like, I'll do it.
Yeah.
I'm already not even gonna be here.
Okay, so our branches all look good, and so basically it's going to call branch 1 in all of those. Yeah, so right now it's pretty much the same as the AGCTs. So it's not basically the same coupling. And in that coupling, so 6 seconds after mixing, then we wash, but the main stuff goes on in the subroutine of coupling. And that's wherever there's a T, it's going to just do this 120. Wherever there's an I or a K or a U or a Q, it's going to add these as wait times. So that's 6 more minutes of wait time. Plus the 2 here. So that'll be an 8-minute total wait time.
Yeah.
Okay. All right,
But
so we
that's
should be able to get
for-
through our
Sorry, that's for the coupling, right? Not
Yes.
the oxidation.
Coupling.
What does WMO mean?
wait for modifier.
Okay.
So when it's just using AGCT, it bypasses those.
Yeah,
It doesn't
yeah.
even.
'Cause it's
doesn't
DNA.
even- yes.
Yeah, yeah.
Whenever there's a modifier, which is the IKU, Q, then it's going to engage this timer.
Yeah. Okay. No, that's fine. That's good.
And in our oxidation step, we'll just take a peek at that real quick. So in our oxidation step, we have basically 18 seconds. We're going to flush out the
To the monitor.
To the monitor, yep.
Yeah.
And right now we know it's clean, but let's go through steps like we would normally go through to start a sequence. So we basically have double checked our subroutines, and we like them. We know they ran previously. So
Can we do double column too? Like
yeah,
2, 2, 2.
yeah. So do you want to do like 4 columns, or
Yeah.
do we have enough material to do? This is what I was telling you the other night. I was telling you we use like 20 milliliters to do, but that's on like a 16 column synthesis. So I think your number's pretty close. You're saying 30 couplings per half gram or per gram?
Yeah, something like that.
Okay, so 30 couplings per gram. And we just ran like a 10 coupling last night. We had a couple of false starts, but we'd say we ran a 10 coupling last night. So you probably only have 20 couplings left on this, the
There's-
AGCTs.
Yeah, we don't.
And you're only going to use like 2 on each of these columns.
Yeah.
But you have to multiply it by columns. That's what I was saying.
Yeah,
is
yeah.
If it's just one column, you got 2 T's, you got 2 couplings. But if it's 4 columns, you got 8.
Yeah.
So these are the kind of things you think about before you start. Do we have enough?
Yeah.
Yep.
It is.
Yeah. So you
Yeah.
think we have enough for
Yeah. We
how
should
many
have-
columns? I mean,
We should have enough RNA in there for 4 or 5 columns at least.
Okay.
I can always fill them up. So take about 6 hours, but I can check it before I leave and make sure there's enough too. I can always add more amidite to the lines if
Okay.
it's not too. If it looks like it's using too much. We should be able to make at least 4 columns with what's on there now.
all right, let's do that. So we basically are going to go 2 and 2. So we're going to go single column mode. So that means my method that I just wrote for that
Virginia.
one column,
Okay.
we'll just use 1 micromole, which has single column mode no. So then it's going to do 2 columns at a time. And do we really want to do that?
No, we don't need to do it. Like how much does it really speed it up? It's a couple of times in 8 minutes. So it's really only speeding up that in between part, right? So it's not really going to save us a ton of time, you know?
Is it? Or oh, sweet.
Does that matter?
Yeah.
What?
Yeah.
Yeah, so the software is designed.
So is
it's
it
like,
also
it's
like
like
that?
yeah.
Okay.
So we tell it the P is on the end, and then it kind of just ignores it. It's the DT column.
Okay.
But you have to select whether it's a DT or a universal column in the software now. It's better.
So right now it's on 15.
Yeah, well, in the software it says AGCT column. Like it doesn't matter as long as the sequence ends in one of those. It'll assume that it's on the column.
Yeah, and then maybe we can make your DNA sequences so we don't run the risk of running out of the RNA sequence while we do this. Yeah.
And we're all using your TT's columns, okay? Okay, so we're using that DNA, RNA, 1 micromole column, which basically is, well, we're saying we don't need to run two. Yeah, that's correct. So we just double check that with the DNA, RNA, underscore RNA. It says we will yes, so next one, 2 column.
What about we're doing 2 columns?
We have 2 columns, but not the double column.
Ah, okay, so
Or the
1 each.
Yeah, so it still does them at the same time.
Yeah.
It
Okay.
just yeah.
Okay, so DNA, RNA, 1 micromole, 1 column is the methods. We're going to go, the sequence is going to be FFL sense.
Yeah. So for the first 2, FFL sets. And the second 2, antisense.
You want to try it? You want to see how to click on? So you click on the column you want, and then you click on the sequence you want. Okay, and now what we want to do is, do we want the DMT on or off?
Did you say yes?
So then you just click on each one of those and they'll turn to yes. And then now we have an AGT or a universal column. So right now we have AGT columns because we have a T. And then we want to choose our method, so both methods are the same, so we can enter a 1. But we could enter 2 because we have 2 methods, but right now we're running both methods the same. But so right now we're in single column mode. We're going to have BMT off. We've got AGCTs. Okay, first thing we should do is prime, just to make sure that we're good. Let's go through some other things. We'll go empty the trial monitor. I know we just did, but let's empty it, clean it, because it's a good thing to get used to. And then wash it. Gas all the way to the waste. So cleaned out whatever's in the lines, and then we empty it. That'll pump it all out. So pumping gas through these openings to the waste. Okay, so we've done that, and when we prime, it's going to prime the AGCT, but it's not going to prime our I, K, Q, and U. So we're going to want to go I, U, K, and Q. We're going to want to do this about 5 times. We're going to want to put them through the column 1, 2, 3, 4. So we'll say.
What you missed?
Okay. Yeah, I think so.
Are you not seeing something happening on one of the columns? Or?
Oh, okay, my bad. So I chose the waste up here. I didn't choose the columns here.
Oh, so it's just going to the.
So now I can see. Yeah. Okay. And yeah, it's a little bubble. So okay, so we were primed on ours, all off, and we're going to prime the reagents and DNAs from the start screen. So we're going to say prime DNA, and that's going to basically give us all the prime of the reagents and DNA. Okay, I think we're ready to start. So tight.
Gotta watch the trail come off, Kevin. Like, you'll see it.
Oh yeah.
Yeah. And then the first few couplings, you'll see the trickle monitor. And then we'll know.
Yeah, and what I'll do is I'll open this side so that we can take a look at it. There's 1,
Oh my
2,
gosh.
3, 4.
Give your sequence.
And then we're going to push a little more and push a little more. And then we're going to gas it all to the trial monitor.
Because we can start that after this. Like we'll start them at any time, I guess. So once they're set up, you can put your sequence in and start your DNA column.
Kevin, come this way.
Except, yeah, if yours has a different method, we might have a problem because
No, it'll be the same method. We're just using DNA instead of RNA. It's the triple, like the
the
DNP.
DMT group.
So it's 8 little vials in the block there, and it collects it, and then it measures it with UV, and then it'll compare the coupling efficiency between each ones. So that little box that says column 1, it'll get like a blue bar saying it measured the triddle, and it'll measure each coupling, and it'll compare them to each other, and that way you'll know whether you had a bad coupling,
Okay.
like you'll see it drop off or whatever.
Yeah, so when I was saying it has the LED and the detector and it looks at the orange color inside that vial.
Column 2 is still orange.
Yep, we gotta get rid of that.
So the triddle is coming off of like this.
Yeah, so the triddle's on the column, right? So when you do a universal column, it has a triddle on it too. And then when you detect it, it's the first step, and then you get that to your next phase. So fresh column should always be orange.
Like that column is flowing, it's not moving. That's the coupling, the amidite and the activator. It's that switching speed we were talking about. See, now that we're in the coupling, we can actually take a look at our trial monitor. We should have 4 nice full vials. See?
So we'll empty and I should have it between each one.
At the oxidizer step, it uses that less than 9-second, or that 9-second or less time to purge that out. And so it's fresh to go on the next one. So coupling is going to take a while each step, you know, it's going to be like
First
5
one is
minutes.
DNA, so it should be quickish, right?
Quicker, yeah,
Yeah,
it's still got the
TE,
2.
and then it's the RNA, which so the estimated synthesis time is. So maybe we'll just see how the first 3 go.
Yeah, yeah.
They look
if-
good,
if
and
the first
then-
3 look good, we're in business, I think.
And then we could start 2 DNA sequences.
Yeah. Yeah, I think you
Wow.
could start writing them now. You know, there's no reason not to.
Yeah, why don't you start punching them in now? Yeah, why don't you go for it, Daisy? We'll, just don't hit stop or pause.
So is that total time 3 hours for the whole thing?
Yeah, so it'll be about 4 hours. It's not half.
Like half the time of this?
It's about the same.
Isn't this 6 hours?
Yeah, like 6 hours-ish. But we shortened the coupling times too. So it's about, for RNA, it's about four bases an hour. So
So I'm making a new sequence.
Yeah.
And
we use the
that's-
DNA editor for this one. So like just ACGT.
Yep, I think that's where she's in now, yep.
Okay,
So
so
this will be easy.
So everything will be capital letters and
If you don't put caps, will it just automatically?
it'll convert the small case to caps in the normal DNA editor. In the Thio, it'll let you have lowercase.
It's a cool sound. With the
Yeah.
top one.
Yeah. So I want to play with that switching speed. See if I can get a different beat. You know? Get some jazz.
Do you want me to double check it? It's always good practice to get someone else to read it. Which one am I looking at?
DNA antisense.
DNA antisense. So maybe I'll just read it back to you.
Okay.
AAC,
Mhm.
AGG,
Mhm.
GTC,
Mhm.
TGA,
Mhm.
CAC,
Mhm.
AGG,
Mhm.
AAA,
Mhm.
T.
Yep.
All right, very good.
Okay. And then do I save? File save as?
I think so.
Yeah, save. And then if it's not saved already, it's going to ask you for a name.
Oh, save. And then I can name this. Can I put my name like DL?
Yeah. You could even make your own folder, but you know, but for now, yeah.
Yeah. And then
And then you want to do the,
Sentences.
complements round two? Or do you want to just do one, or what were you thinking? Because there's two more columns, so you could do 2 and 2 if you wanted.
okay, so with the sense you said that just do it up to like this and you'll add the outline.
Yeah, you can add the alpine later. And then once we get that, it's actually probably better you build them all this way, then we can do all the alkynes like at once. When you get all
Okay.
your sequences, like you can just spend an after and doing that.
Mhm.
So how many of these do L9 on that?
Boy, they probably have maybe 3 or 5 of these, but I know they have like a few of the Shastas as well, the big high throughputs.
Oh yeah.
So, and Lily is the same way. Lily's got like 5 Shastas and 20 of these or something like that.
Yeah.
Some crazy number. We spend a lot of time with it.
Yeah, I think this one is sort of you wanna.
ETT,
Mhm.
TCC,
Mhm.
TGT,
Mhm.
GTC,
Mhm.
EGA,
Mhm.
CCC, TGT, then T.
Yep. Okay. So should I say no alkyne or does it matter?
Yeah, it's however you want. This is for you, right? No one else is gonna make these sequences, so you need to figure out what makes sense.
So the alkyne is not like connected to the base. It's just
Yeah.
added on in there.
Yeah.
So you'll have to pick a jar and then just make a sequence with just that one letter, right?
Yeah. But yeah, it's not, I mean, you can treat it like a base. Yeah. So you'll have an anodine.
But it's this, yeah, it's the same method, like the same
Mhm.
protocol. You just do one coupling.
Yeah. Y or Z or, you know, any of those.
So what I'm asking is if the last letter in the sequence is
Pick
A,
one that's not assigned.
Mm-hmm.
I still include A in the sequence because the alkyne is not like an
Yeah,
A with an
yeah,
alkyne.
that's
You
right.
can designate a couple as special anodite lines.
Yeah, it's not like an A attached to
Mhm.
it.
We
Yeah.
can pre-map it.
In your case, yeah.
So we'd say like
And then
J and E are for
here.
like the ones we name.
Okay, so we can look at the couplings. They look pretty good.
Just pick one of the first two, right?
Yep. So that means things are working. So we can't trust the reading yet because it doesn't have a V2 number yet. But if you click on one of these, double click on it, so that tells you you got 100% yield at this point. So double click again and it'll go away. And now what we're doing is we're just waiting for that next, the third line will tell us really, it'll give us a V2 number and tell us how we're doing. And if something goes really bad, now's a good time to stop, you know, and you can kind of regroup. But,
Yeah. So now if Daisy wants to add those sequences, she can add them right now, right in the middle.
Yeah, right in the middle here. So you basically just same thing, click on click, and then add your sequences. And like I said, since I used both methods, I don't think you can use. So now you've clicked there, go and click your sequence.
Maybe double click.
Okay, maybe it needs to be paused first before we do that. So let's wait until we get that third V2, then we'll put it to pause and it'll stop after the coupling, then we'll
Okay.
populate it. You know,
That might make sense, because then if it wants to, like, to do something, want to do it together.
Yeah.
Yeah,
like
it'll be out of sync, I
It'll be
guess.
out of sync,
Yeah.
right?
Yeah.
So that actually makes sense. Alright, so probably, I'll turn this off, but